Hello everyone, this video is for lesson 15, which deals with our angle chart. So what we're basically going to do throughout this lesson is fill in a chart of different vocab terms that somehow relate to different angles. So the first couple that we're going to go through we spoke about before, and we're going to add a definition, a diagram, an example, as well as notation if it applies. So we're going to start with midpoint. So down here we have a diagram with M being the midpoint. And since M is the midpoint, we know by definition that means that that's the point that divides this segment into two equal or congruent parts. So with that being said, we can mark that the parts are equal from A to M and B to M. So over here, AM is equal to BM. Now if two parts are equal, they are also congruent. So if we take a look at what we have, AM equals BM, and segment AM is also congruent to segment BM. The bar on top means segment, and this symbol right here is congruent. So if these two segments are equal, for instance, if this measured 5 from A to M, B to M would also measure 5. So that point right in the middle divides that segment into two equal parts. Next, we're going to go into the term bisect. So what does it mean to bisect something? And that simply means to cut it into two equal parts. Now notice the difference. Midpoint specifies a segment. When you bisect something, you can cut either a segment into two equal parts, you can cut an angle into two equal parts. I know it's silly, I say in class. You can also cut a piece of pizza into two equal parts, piece of chicken into two equal parts. So bisect means we're just dividing it into two equal parts. So if you take a look at this diagram that you should sketch into your notes, and remember you could pause the video. I'm going to keep talking though. AB is a segment and CD is a line. So only AB is being bisected by CD. So CD bisects AB. Put a little arrows on the end of AB at M. Okay. So with that being said, that means I now know that AM and BM are equal, right? And if they're equal, like we said before, they're also congruent. That also makes M the midpoint. When it bisects a segment, it goes through the midpoint. Now, something that we want to also show you is we talked about an angle bisector. So quickly, if I sketch an angle down here, and I kind of looks like I bisect it like this, right? An angle can be bisected into equal parts too. So for instance, if I just put little arc marks here and here, make this a little bit closer. So two little arc marks. And if I say that the whole thing is maybe 50 degrees, right? So this whole angle is 50. That means each piece, each tiny angle is 25. Okay? So just like a segment being bisected, an angle can also be bisected. Follows the same idea. Okay, moving on. Next, perpendicular. So this is a term we always get confused with. So perpendicular lines look like this. This is a symbol notation for perpendicular. Perpendicular lines don't have to bisect anything. Perpendicular lines always, however, intersect to create 90-degree angles. 90-degree angles are also known as right angles. So if we say 90 degrees or if we say right angles, they could be used interchangeably. So here's a diagram. Notice how we explicitly drew this. These two lines are perpendicular. Now they could also be segments that could be perpendicular. They don't have to be lines. And we can say now, by using the symbol notation, that AB, line AB, put little arrows at the end, is perpendicular to line CD. Okay. So this is what it looks like to be perpendicular. Typically, we show that lines are perpendicular by drawing in that little box. So now this little box is going to lead us to right angles. So perpendicular lines form right angles. Right angles is simply just an angle whose measure is 90 degrees. We show that we have right angles by putting in this little box. So if I show you this, and I tell you that these two, really we have a ray and a line, if they're perpendicular, so let me just put a line CD and ray BA, are perpendicular, my right angles are formed where the two intersect, so right here at B. Put a right angle here and a right angle here. Now, what is important about right angles? This is the right angle right here, and this is the right angle. Remember, we can name angles by using 3 letters. So D, B, A, and C, B, A are both 90 degrees because they're right angles. What's important is that when we're dealing with right angles, we have to make sure we always recall that all right angles are equal or congruent. However, if they're equal, they're congruent. So all right angles are congruent. A little congruent symbol. Okay. So down here, I could also just make the statement that the measure of angle DBA equals the measure of angle CBA. If they're both equal to 90, then they're equal to each other. So I'm going to add that one down there too. Okay, so moving on, now we're going to start classifying angles. So when we classify angles, it means that we're giving the type of angle. So the first classification that we can classify an angle as is acute. So an acute angle is an angle that measures less than 90, but must be more than 0 degrees, right? So in a number like 45, 80, 89, 1 degree, those are all considered acute angles. Think of them as like tiny angles that, are cute. The next classification would be an obtuse angle. So here's a diagram, and you can tell that this angle is definitely greater than 90. So for an obtuse angle, this angle has to measure more than 90, but has to be less than 180. 180 is your straight angle or your straight line. So for this, we have, we could like say here, if we name this angle B, for instance, we gave a measure to angle B, we could say that the measure of angle B equals, I don't know, maybe 110. This is an example of an obtuse angle. It's more than 90, but less than 180. Okay. Continuing on, a straight angle. That's when we get to 180. So a straight angle is in fact, looks like a straight line. Opposite rays form a straight angle. So we know here that the measure of angle AEC, even though it looks like a line, it really is an angle, right? So from here to here, it's an angle. This is 180 degrees. The measure of angle AEC is 180 degrees. Now, there's a certain type of angle that we have when you get past 180. We don't deal with it too much in our course, but it is important just to kind of let you recognize. When an angle measures more than 180 but less than 360, it's known as a reflex angle. So that looks like something like this. So this is my angle here. The reflex angle would go from here all the way to here. That's your reflex angle, right? It's clear that that measure is more than 180. That might even look like, I don't know, maybe maybe 300. So this is definitely more than 180. That's the reflex angle. It's that bigger part of the angle. In here, this part's the acute angle. This is the reflex angle. More than 180, but less than 360. Okay, moving on, we now have vertical angles. I would like you to put a huge star next to vertical angles. Vertical angles will come up time and time and time again in this class. We refer to vertical angles in all different topics, all different units, and these are angles that are opposite each other when you have two lines, two segments that intersect. So you get vertical angles when you're given this like X diagram, right? So it looks like this. Let me see if I can get this to turn. It could really be anything like this. As long as you have two lines that intersect or two segments that intersect, that form these angles here, you get your vertical angles. So the angles that are opposite each other or angles that are like across from each other, that's another way to think of these vertical angles. So opposite or across from each other. Here and here. There you go. So where are our vertical angles? And we can take a look. So let's look at maybe angle 3 first. Angle 3 is opposite or across from angle 4. Now, what do you notice about angle 3 and angle 4? You may be saying, well, they appear to be acute angles. And the answer is, yeah, you're right, they are acute angles. They're both acute angles and they actually are the same measure. So for instance, if I said that angle 3 was 50 degrees, well, guess what? If this is 50 right here at angle 3, and the angle right next to it forms a straight line with it, right, because it's a straight angle, this angle would have to then be 130. Because remember, we said before, a straight line or a straight angle sums to 130. And now take a look. These two angles are on a straight line. So if this is 130 and has to add to 180, I have another 50. And voila, they're equal to each other. But now look at 1 and 2. They both look to be obtuse, and if this is 50, well, hey, this one has to be 130. And this is how we show that vertical angles are also equal. So let's write a couple of things down. And let me finish marking this. I'm also going to mark that angle 1 and angle 2 are equal. I'm going to put 2 arc marks there. Like that. Okay. So first, what do we know? Well, hey, we said 1 and 2 are vertical angles. 3 and 4 are also vertical angles, right? So since they're vertical angles, they're immediately then congruent. I know that vertical angles must be congruent, therefore they have to be equal in measure. So not only is 1 and 2 congruent, 3 and 4 are congruent. Because 1 and 2 are vertical angles, as are 3 and 4. If they're congruent, they're also equal in measure. So I'm also going to put measure of angle 3 equals measure of angle 4. Right. Vertical angles are huge. We really need to make sure we're kind of see vertical angles, we're thinking they're equal, and it's good to go. Okay, moving on to angles or to something that we call a linear pair. So if two angles are a linear pair, I'm hoping that in linear you see lines, right? And a pair means two. So the definition of a linear pair are specifically two angles that are adjacent and supplementary. So if two angles are adjacent, it means that they're next to each other. If two angles are supplementary, well, we're going to talk about that next, but supplementary means that they add to 180. They come to 180. So take a look.
Could a high school custodian please call the main office? A high school custodian please call the main office?
I'm going to number this 1 and this 2. So I specifically know that these two angles would be my linear pair. They form my straight line, right? They have to be on a line. A linear pair must be on a line. Linear pair. Move this up here. Okay. And then obviously if they're on a line, they're going to equal up to 180. So I'm going to just over here, put this, right? And we do 180. You'll see us a lot kind of doing this like little half circle, semicircle through the line to show that it's 180. So here's the difference. A linear pair is specifically two angles that are supplementary and clearly on a line. If two angles are supplementary, it doesn't mean that they have to be on a line though. It just means that they have to sum to 180. So take a look. Supplementary angles are clearly two angles whose sum is 180. So these two angles are supplementary, but they don't have to be on a line. So think about this. I'm going to show you an example. A little arrow down here. I can give you two angles. to be here, and here, and then here, and here. And if I make this angle 60, now, here are two angles, and I'm going to call this A and this B. Angle A and angle B are supplementary angles. They both add to 180. However, they're not on a straight line. So this would again be an example of supplementary angles, but it's just different because they're not on a straight line. Okay, so it's just important to see that these two angles add to 180 and they're not on a straight line. Something else I like to do with supplementary, and I'll do it up here. So remember that they add to 180, you could put the 1 in front of the S, make the S into an 8, and then make the U into a 0. Kind of remember 180 like that as well. Okay, now something else to kind of get into our heads, that angles can also just form a straight angle or a straight line. So take a look at this. This is a straight angle. These are a linear pair. I could also do this and I still have a straight angle, right? I could put in some angle measurements. I could say this is 20, this is 50, and maybe this is 110. These three angles form a straight angle, and they still add to 180. So these angles are not supplementary. Because there is more than two angles. Okay, so these angles aren't supplementary because there's more than two angles. However, those angles still form a straight angle. Okay? Again, all different little pockets of information that even though we know what supplementary angles are, we may think that these are supplementary. Supplementary simply means that you have two angles that sum to 180. Okay, after supplementary, we must then discuss complementary angles. So complementary angles are two angles whose sum is 90 degrees. So here you most often see complementary angles with the little right angle box. However, like supplementary angles, they don't need to form a right angle. So it's really just any two angles whose sum is 90. So as long as A and B add to 90 degrees, or the two angles add to 90, they're considered complementary. Maybe they're adjacent and form a right angle, maybe they're not. Okay? And then finally, we have angles that meet at a point. So take a look here. All of these angles share this point right here in common. And if I go from one angle all the way around to the other angle, it forms a big circle, right? So here it gave me a box, here it's giving me a circle. These angles that meet at a point are angles whose sum is 360. So this then I could say the measure of angle A plus measure of angle B plus measure of angle C equals 360 degrees. Okay. And that really finishes up our chart in terms of understanding the angles and the relationships that form based on those angles. So what we're going to go through now are just some quick little diagrams and try to figure out if we can solve for the missing angle and give a reason. So first here I take a look at this and I'm going to ask myself what I should be doing is I should be going back to my chart and I should be looking and say, okay, well what does the diagram look like? So I'm going to go here and I look at this diagram and immediately I notice they all meet at this point. So if I go from here all the way around, this is a 360. These are angles that meet at a point. Right? So I know it's 360. They have to sum to 360. So that means now I can write an equation. my equation would be that all three of these angles have to add to 360. So I start by saying 133 plus 147 plus G equals 360. Right? Once I have my equation, I can solve, and really we're focusing on the geometry. If we're going to do the algebra here, I know once I combine my terms here and I subtract from 360, that G is going to equal 80. Okay? So that's what we're going to be doing for these. So this one, our angles that meet at a point, they sum to 360. Over here, I have two intersecting lines. So that means I'm focusing on just these two angles here and here. Prime example of vertical angles. So here I know that vertical angles are equal. Well, that's pretty easy. That means that this angle equals this angle. So H equals 52. Done. Vertical angles are easy. They're equal to each other. All right, moving on to this one here. Oh, again, intersecting lines, vertical angles. So vertical angles are equal. That means that x equals 36. Neato. All right, this one down here. Well, for this one, it looks like I have a straight line, and there's 2 on the line. So these are a linear pair. And if you remember, linear pairs sum to 180. So for this, we have a linear pair, and they sum to 180. So again, we can write an equation, y plus 121 equals 180. So that means if I subtract 121 and I solve for y, I get that y equals 59. So again, I'm kind of writing what it is that we're applying, the relationship. I'm writing an equation, and then I can solve. Next page. Okay, so again, all three of these angles appear to meet at this point here. So this is an angles that meet at a point. That means that they sum to 360. So angles that meet at a point, 360 here. Our equation would be that all three of these angles, z plus 82 plus 172 equals 360. If we combine like terms and then subtract, we actually get the z equals 106 here. Right. If you need help with the algebra, we did that last Friday, or 2 Fridays ago, excuse me. But certainly reach out to us. We can go over an extra help of how to combine like terms and subtract, but this is the algebra. That's the algebra portion. Okay, so now this was an interesting diagram because there's a lot of things happening. First, I see this little box. So that tells me I have a 90-degree angle. And I always like to mark that first. The other thing is anytime I have a straight line here, I always like to do this. Right? Now, what this tells me that all these angles add to 180. But these angles are not a linear pair because there's 3 of them. Remember, linear pair is 2. So these are just angles that form a straight angle. That means that they sum to 180. So we have 72 plus 90 plus f equals 180. So if we combine like terms and subtract, we find that f is 18 degrees there. Angles that form a straight angle, we get f equals 18 degrees. Okay. Now let's kind of go through these, or maybe you may want to go through these. I'm going to, if you want to pause and try them, I'm going to kind of go through them again. I'll show us what the relationship is, write the equation, I'll give us our answer. So here we have, again, a 180 because they're a linear pair, so they must sum to 180. So we can write the equation that 144 plus a equals 180. And when we subtract and we solve for a, we find that a is 36 degrees. Here, it's similar to number 1, however, there are 3 on the straight angle. So these still sum to 180, but they're not a linear pair. They're just angles that sum to 180. So it's 97 plus b plus 360 equals 180. Again, if we combine like terms and solve, we find that the measure of angle B is 47. Now, 3, you could do it a number of different ways. So for 3, I like to keep with that I have a straight angle here. The only difference about the straight angle is there are 4 angles that make up this straight angle here. There's 40, 36, C, and this box, which tells me that it's 90 degrees. So I'm going to stick with 180. Even though there's 4 angles, it still has that 180 relationship. So we have 40 plus 36 plus C plus 90 equals 180. So again, combine like terms, subtract, and we find that the measure of angle C is 14. Okay. Next page, we have number 4. Take a look, straight angle. Put in my half circle, 180. So we have D plus D plus, actually I'll do D plus 82 plus D equals 180. So you can kind of see what we're adding there. Combine like terms, subtract, then we'll have to 2D divided by 98, and we get then that it is 49. So you're solving this equation and we're getting 49. Here, all of these angles meet at the point right in the middle. If we're a big circle, 360. So the equation that we write here, start here. We have G, 91, G, 91, G, 91. We have G plus 91 plus G plus 91 plus G, 91 equals 360. And for this one, right, you want to combine like terms, subtract, then divide, and we find that G, see, we get 29. Just to kind of give you a little, after this, when you combine like terms for this one, you get 3G plus 273 equals 360. And then you subtract 273 from both sides, you get 3G equals 87, then divide by 3 to get your 29. Okay, and then finally we have this one down here. Again, angles that meet at a point. This is a 360. You start here and kind of work your way around. So we get x plus 35 plus 2x plus 85 equals 360. We can go ahead, combine like terms, and we have that x is 80. So again, quite a lot of practice. I would suggest that you pause this earlier, you try them by yourself, and then you check your work with our answers. If you have any questions with any of this, please feel free to reach out. By the end of this, you hopefully now understand the difference between complementary and supplementary angles, angles that meet at a point, linear pair, vertical angles. These are all the relationships that we're going to see over and over again. If you have any questions, please comment on our Google Classroom or email us.